Now let's just talk about I all by itself. Okay, so when I think of I equals I. And now let's talk about I squared. We know I squared is -1. Okay, and we know that because that's what was given to us. Now let's take a look at I cubed. Now I cubed is really I squared times I. Okay, and what is I squared? If you look at the previous one, I squared equals -1. So this is really -1 times I, which actually equals -I. Okay, now just kind of humor me through this. This is kind of a nice idea. Once I get this idea down, we can really extend it to a lot of different types of problems when it comes down to simplifying powers of I. Okay, so then I to the fourth. One way to look at this is this I to the fourth is really I squared times I squared, which is really just -1 times -1, which equals +1. So when I look at these four powers here, I get I equals I get I squared equals -1, I get I cubed equals -I, and I get I to the fourth equals 1. So now I'm just going to keep going. I'm probably going to go till about 10. So if you can, hang on for a minute. I'm going to show you something here. So now I to the fifth. Let's take a look at that one now. That's really I to the fourth times I. And I to the fourth, if you look at the previous one, equals 1. So therefore, this is 1 times I, which is I. Okay, now I to the sixth. Okay, this is really I to the fifth times I. I could look at it that way. Or I can look at it as I to the fourth. Oops, let me write a better 4 than that one. Times I squared. And the reason why I'm picking I to the fourth is I to the fourth actually equals 1. That makes it easy to say, hey, I'm multiplying 1 times this I squared or whatever it is. So that's really just going to be I squared then, isn't it? Which is really -1. Okay, so then I to the seventh. I'm going to think of that as I to the fourth times I cubed. And that I cubed is really -I. So then I to the eighth is really I to the fourth times I to the fourth, which equals 1, because they're both 1 times 1. Okay, now let's go I to the ninth. Hopefully you're getting bored of this already. No kidding. Hopefully not, because this is a really cool idea. All right, so this is really I to the eighth, because I to the eighth is 1, isn't it? Because it's a multiple of 4 in terms of powers. All right, so that's I to the eighth times I, so that's going to be I. So now let's go a little higher now. Let's go down a ways. Okay, let's go down to I to the 64th. So now I to the 64th is really 1. Because 64 is a multiple of 4. And if you notice, anytime I get to a multiple of 4, it's back to 1 again. Now when I look at the pattern completely here, take a look at this. I to the fifth equals I to the sixth equals -1, I to the seventh equals -I, and I to the eighth equals 1. So I'm going through this pattern here every 4. So I'm going I, -1, -I, 1. I, -1, -I, 1. So that's the pattern I'm looking at here. So every fourth, I should say, every multiple of 4 for my exponent is going to be back at 1 again. So I to the 64th is a multiple of 4, so that's going to get me back to 1. Now let's try this one. Let's try I to the 81st. So now I to the 80th would be a multiple of 4. So times I, the answer is I. So now let's go I to the 281st. Now all I'd have to do here, I'd have to use my calculator here, I could just take that 281 and divide it by 4 and find out how many times it goes into it. So it goes into it 70 times, I can see. And I have 1/4 left over. So I have 1/4 left. So this is really I to the 280, which is 1, because 280 goes in is a multiple of 4. And then I have I, so this is also I. So that's one way we can go through that very easily. Nice idea.